So really, the interpreting in this context of the problem is that it is your exchange rate for that day. And I changed these numbers just yesterday when I made these notes. So this was the exchange rate when I did this, was this on the 9th? So, okay. So what it means is that the gradient represents for every euro. I'll do 1 euro. Let's put the 1 after the euro symbol, not before, like a crazy person. So 1 euro. For every 1 euro, it is equal to 118 US dollars. And that's all it's saying, is that it's asking you to compare then this unit rate. That's it for the context of the problem, context of the slope. Okay. We have one more example. This is your big IB type of problem. Okay, the ski slopes in Val Gardena are marked by color as an indicator of the incline. The colors used are green, blue, red, and black. Green is for slopes with less than 20% incline. Blue is for 20 to 25%. Red is for 25 to 40, and black is for above a 40% incline. So we want to classify the following slopes, and we're given all of this information. The first thing I want to talk about is the fact that we are not indicating at all whether or not this is a positive or a negative slope, because it's really just a matter of perspective. If you're looking from one side of the mountain at the slope, it might look like it's going up from left to right, and then maybe if you look from a different side, maybe you're on a different gondola, it might be looking like it's negative from the other side. So it doesn't really matter. All of our slopes can just be positive, just as long as you're consistently subtracting from 0 or subtracting 0. So just keeping those consistent. Okay, so if our horizontal change is 450, that is your change in your x values, so that goes in the denominator. And then a vertical change of 280 goes in the numerator. If we go ahead and find that as a decimal, the answer is 0.622. Which is a pretty significant incline. It's a pretty significant change. Yeah, that's a pretty significant change. Sorry, I had to take a second and think about it. That's a pretty significant change, and that's greater than a 40%. Remember that 40%, so 20% is represented as 0.2, right? 20 to 25% would be 0.2 to 0.25. So a 40% incline would be 0.4, and this is greater than that. So this is a black slope. Okay, let's try the next one. Our next slope has a horizontal change of 150 and a vertical change of 50. If I were to subtract that out, that's 0.3 repeating. I'm going to double check. Yeah. Since that's a 0.3 repeating, that falls between a 25 and 40% slope, which means that this is classified as a red. Okay, we are represented this data in a different way. We're given the very top of the slope, and then the end of the slope, which means we're just given 2 points. Make sure that you're consistent in your subtracting, and I want you to go ahead and find out what the slope is for part 3 of A. Okay, so as long as you're consistent, you could do 0 minus 310 or 310 minus 0 in the denominator, because that's your x value, and then your y value just needs to also follow suit. So that's 48 divided by 310, which is 0.155. That is less than 20%, right? Remember that 20% is 0.2 and this is 0.15. So then this would be classified as a green. Last one I would like for you to do on your own. Okay, so we are going to graph all of these slopes on this right here. We've got only positive values. So that means that my axes can be drawn such that I only am focusing on positive values. I know that my largest x value is going to be 450. My largest x value is going to be 450. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So 450 divided by 19 is 23 point something. So if I go up by 20s, no, I need to go up by 25s. I did 20 times 19 and I got to an answer of 380, which is less than 450. So if I do 25 times 19, that gets me to 475. So that is how I know that this needs to be 25, 50, 75, 100, 125, 1, 2, 3. This is 200, 1, 2, 3, 300, 400. Okay. Then on the y-axis, my largest y value, okay, I'm going to make a decision here. I'm going to keep this scale the same because if I keep the scale the same on my x-axis as well as on my y-axis, I can then count my slope. Never mind. I'm going to talk about that at a later date. If I kept the scale the same, if I had a slope of like 2/3, then I could count down 2 blocks and over 3 blocks and could show it that way as long as my scales are consistent. Even though it's going up by 25s and not by 1s, that's totally fine if you count it as like 1, 2, 1, 2, 3, only if the scales are consistent. I'm going to keep the scales consistent here just because I want to be able to see what it looks like. So that's 25, 50, 75, 100. I think my largest, my largest X value is 280. So I just got to make sure to get up to there. 1, 2, 3, 200. 1, 2, 3, 300. Okay. I'm first going to represent my black slope, so the I one, and it says that I had a horizontal change of 450, which means I'm out to here, 450, and then a vertical change of 280. So 450 to 280. If this is 75, then 80 is going to be just slightly above it. And we know that all of these start at the origin. So all of our points are going to go back to the origin. So I don't even really have to look at the slope. I'm drawing it in black because it's a black slope. I'll draw all the other ones with their respective color. Okay, so then a horizontal change of 150 for number 2. So horizontal change to 150. And a vertical change of 50 means that my point is right here. And that would be the red slope. My green slope has the top at 310, and then the y value is 48, somewhere around here. And then our blue slope is 230 and then 56. 230 is going to be above 225, but not by far. And then 56 is going to be like right here. Okay, very last problem. This is a very IB thing. It says determine the angle of inclination, which is alpha, of the slope P2. The slope P2, if I were to kind of like redraw this, had the point, a horizontal change of 150 and a vertical change of 50. So it was like something like right here, with the x value of 150 and the y value of 50. What it wants us to find is this angle, and we call it alpha. I want you to realize that as I draw this line down, that it makes a right angle. And what we end up having is a right triangle with a point right here. This is all really great information, because what it's going to tell us is how we can label the sides of our side length. If of our triangle. If our horizontal change was 150, that means that we went this distance of 150, which means that that side length is the measure of 150. And then the vertical change is representing this distance right here. So if I wanted to solve for this angle of a right triangle, first of all, what type of trigonometry would I use? Hopefully you said SOHCAHTOA. Remember that right triangle trigonometry, it's either Pythagorean theorem or SOHCAHTOA. So make sure that you're using that SOHCAHTOA acronym to help you out. Now, using the acronym, next question, which trig function would I use to represent the relationship of the things that I want to talk about? I want to talk about this angle, this side length, and this side length. So how do they all relate together? Which trig function? 50 is opposite of your alpha, and 150 is adjacent. This is your opposite, and this is your adjacent. So remember, opposite and adjacent means tangent. So setting this up, we have tangent of theta equals your opposite over adjacent. From here, you can either use your inverse trig values, so that's your tan to the -1. Remember that your inverse trig flips your inputs and your outputs. What was your output now becomes your input, and what was your input now becomes the output. So it's tan to the -1 of 50 over 150, and that gives you alpha. Or you could use your numerical solve. Go ahead and tell me what the answer is. The angle of inclination is 18.4 degrees. So you should have just gone ahead and put it into your calculator. You can see in mine, I just did tan to the -1, 50 divided by 150, and there you go. If you did not get this answer, if you got some crazy answer instead, please make note of this guy up here. This should always be in degrees. We will never be in rad. We'll never be radians. You won't learn what that is, so just make sure that you're always in degrees. Okay, and those are our notes for today. We're just focusing on gradient today, just slope, and how do we apply that in a IB way. This was all just about slope. That's it. Great job.